Hello, this is Jesus, and I want to present a small, very simple project in Machine Learning Studio from Azure. And so we have a very simple machine learning project like this can be integrated in a typical Excel sheet or decisions in Microsoft Office in Cloud in Azure. Okay. We can, once we are in Machine Learning Studio, we choose the test project. The project is very simple and is based on the analysis and prediction of delay times for specific flights. The dataset we are using has been created from a CSV file. Here we have specific data from flights with some information. This is the base structure of data to build the features that will be analyzed in the algorithm. Basically, they are very simple. Basically, the year, month, day of the month, day of the week, the airline, the origin airport ID, destination airport ID, basically their CRS departure time, departure delay. This is a very important feature for our purposes. Basically, this is our binary classification about the flight was delayed 15 minutes delayed in the departure. 0 is false, 1 is true. CRS arrival time. The arrival delay is the real delay of the arrival of the flight in the past, so it will be very useful to calculate and predict the final arrival delay for future flights. And the arrival delay 15, that is basically true or false, or if the flight was 15 minutes delayed in the arrival, and if the same for cancel, that if the flight was finally cancelled or not. Okay. We have this file is not very long, and the structure is simple. So a different set of data with more features, or much more flights, or the precision and the accuracy of the analysis can be much bigger. Okay, the plan for the analysis in machine learning is purely visual, so we have not written a single line of code. And basically what we've done here is to do some filtering of data, and in this case for a relational expression to delete all the flights that were cancelled, because finally the arrival delay is not useful for us. And the second phase, we select the specific columns from the dataset. So this is a very simple feature engineering. So that's we are using specific columns from the original data. In feature engineering, we can use or transform features from from categorical to numeric, or transform data in the way we are interested in order to get the more information we can. In this case, we have selected the day of the month, day of the week, the origin and destination airport IDs, and the time of delay for arrival and departure, and the airline. This apparently is not very useful, but maybe some airlines can be more prone to to provide delays to the flights than others. Once we have filtered the columns, we have split the data again. So we have in this case, in this phase, we are selecting a fraction of the data set to train the model. Okay, in this case we are using 80% of the model to train the data. The rest, the 20% of data, will serve as test data to check to get metrics from the model and to check out the accuracy and precision of our model. Okay, the algorithm we use is linear regression because we need specific figures for the prediction. We have selected the solution method, the ordinary least squares, with L2 regularization weight of 1 divided by 1000. So the weight is light in this case, so a random number seed. In this case, that can be reusable across different usages of the project. In this case, for training the model, we have used, if I included only the column that will be the object of the prediction, this is the delay, the prediction for the delay in arrivals, and we get the final prediction from the score model. Okay. In this case, the column score labels is the prediction for the test data, right? So these are the columns that has been converted to features to train our model, and the score labels column is basically the predictions. The last phase here is to evaluate the model. Okay, so evaluate the model, we get some metrics for this specific algorithm for linear regression. Well, in this case we have several metrics: the mean, absolute error, the root mean, square error. There are but more important ones. We have 8 and something and 11 and something. So this it's not good, but it's not bad. It's just a good starting point to start tuning and to improve our model. Okay. The other one, coefficient of determination, is just a value between 0 and 1. So 0 is that your prediction is totally useless, and 1 is your prediction is 100% accurate. In this case, 0.85 is not too bad. So we have a good starting point for our model. Okay. So basically, it's quite good if you consider that we have not written a single line of code, that we are used just some tuning by using the Machine Learning Studio visual tools. Okay. In this case, we can create a web service. The web service that is very easy to create with Machine Learning Studio. And for example, let me check, because this web service is already created. We go to automatically the machine learning project will be created as a web service. Okay, so if we click on deploy web service, we'll get to access to the web service a specific API key that we'll use to connect to the web service, and the URL to connect to this web service. In this case, for example, you want to see moment. The URL is something like that. Okay, we have created a model in Machine Learning Studio, and then we can go to Excel online in Azure to include to get the predictions directly on Excel. So in this case, we need to add the Office add-in. We'll include here Azure Machine Learning stuff. So now it's added. We can include here the URL and the API key. So we have added the web service, and then we can include some specific test data. We can this is, as we said before, these are basically the data that will be the base for the prediction. These three columns in the data are empty because precisely we need the prediction for the R delay column to know each of the real delay, the predicted delay for the arrival of this flight. Okay, in this case we have included the key and the URL to the Machine Learning Studio, adding the extension in Excel to connect to the web service in Machine Learning Studio. So we have included the set of data as a part of the data there that will be the base for the prediction, and we have included one cell as the starting point to the inclusion and insertion of the prediction. Okay, so by clicking on the predict button, we'll connect to the Machine Learning Studio project, and we get here in the score labels column the prediction right for this code, for these specific rows. So we have got here very easily data prediction for some specific data that we can get from CSV file or other Excel files or in our library in Azure or in Excel Online. Okay, that's all. Thanks.